All right, today's lesson is pretty crazy. We take a couple of very interesting leaps with this material. So geometric series, they're so easy. Whether they, I mean, hopefully you buy the hype and you agree that we can take an infinite number of numbers and add them up and get a sum out of it. We're going to kind of leave that a little bit. So ignore this for a second. We're not really going to have a series anymore where we find out numerically what this answer is. We really start to think about, does a series converge or diverge? Not necessarily always able to find a sum. So we start to get into a much more theoretical conversation, which gets a little weird. So what I want to do today is talk about taking what we know about a geometric series and making a geometric series more generalized. So instead of a geometric series being numeric and having all these numbers that get added up, we want to look at this as more of a variable thing. And then we might have some restrictions on that variable because we know that geometric series only converge when that multiplier, or when the absolute value of that multiplier is less than 1. Let me also say this. I hope everybody understands that when I say the absolute value of r is less than 1, that means the same thing as r has to be between 1 and -1. That's what that means. This is a fancy way to say that. They mean the same exact thing. So that's something that you did in like Algebra 1 when you talked about inequalities, but that's been a really long time. So I just wanted to make sure you see that when I say the absolute value of r has to be less than 1, that's the same thing as saying r has to be between 1 and -1. Remember, absolute value is the distance away from 0 that a number is. So if the distance away from 0 is less than 1, then that number has to be between 1 and -1. So anyway, we know that geometric series will converge whenever that multiplier is between -1 and 1. Okay, so what? So let's start with taking something that is numeric. Let's start with what I just put up there. Let's start with the 1/2 to the n. Which is definitely geometric. So start to also see that when you see series that look this way, a number to a power of n, that's going to be geometric. A general form of a geometric series is usually, maybe we'd see it like as a to the n to the n. I don't know, never mind. But yeah, when we see that kind of form, when we see something raised to the power of n, we know it's going to be geometric. Now, if we were divided by like n, that's different. But if we have a term raised to the n power, this is going to be geometric. So let's say it was last week, we were like, okay, so this is going to be, if we're starting at n being 0, we're going to have 1 plus 1/2 plus 1/4 plus 1/8. And we would check our multiplier and we would say, okay, our constant multiplier, which we call r is 1/2. So because 1/2 is between 1 and -1, we know that the series will converge. And because we have numbers, we know that not only will the series converge, but we know what the series will converge to. We know what the sum of it will be. We know that the sum will be a over 1 minus r, a being the first term, r being the multiplier. So we know a lot of stuff about a series that's geometric as long as it's numeric. But what about if it's not numeric? Take some of this away. What if I have a series that's a variable? So what if I have this? So this is a series also. I just said that funny. This is a series also. But this is a series. If I plug in 0, I get 1. If I plug in 1, I get x to the first. If I plug in 2, I get x squared. So this is a geometric series. All that I need for a series to be geometric is I need to have a constant multiplier. So that constant multiplier, r, is x. So this geometric series is the way we're going to start to look at things. Instead of them always being numeric, they're going to be variabolic. Is that a word? They're going to consist of variables. So in this case, we know that the first term is 1. The multiplier is x. So as long as x is between 1 and -1, this series will converge. And as long as x is between 1 and -1, this series will converge to a over 1 minus r, which in our case, we have an a, we have an r, 1 over 1 minus x. Okay, what the heck does all of that mean? It makes sense on paper that, okay, if the number that's my multiplier, if the thing is my multiplier is a number, this makes sense. I have a multiplier that's a half, so this will converge to 1 over 1 minus 1/2. Now I don't have a multiplier that's numeric. My multiplier is x. This will converge to 1 over 1 minus x, as long as x is between -1 and 1. So now there's a big connection to make. Can you see all this? There's a big connection to make that's out there. And that is, every series can be written as a function. Or I shouldn't say that. Lots of series can be written as functions. So this series, 1 plus 1/2 plus 1/4 plus 1/8, can be written as this, which would be 1 over 1/2, which would equal 2. So these numbers add up to 2. Okay, so if I were to like graph 1 plus 2 plus 4 plus 8, I would get 2. And if I were to graph 2, I'd get 2. I'd get the same thing. Well, guess what? If I were to graph this polynomial or this series all the way out, I get every x in there. X to the 1 million. I get x to the 7 million. I get x to the 10 billion. If I could graph this entire polynomial, it would look exactly like this function, as long as x is between -1 and 1. And that seems crazy. Let me kind of show you what I mean. If I graph 1 minus 1 over x, so let me see if we can see this. So if I graph 1 over 1 minus x, that's what this looks like. This function, 1 over 1 minus x, should look exactly the same as this series, or as this polynomial, if I could graph every term in the polynomial, which I can't. But this polynomial, this series, will only look like this function when x is between -1 and 1. This has a fancy name. I'll get to that in a second. So I'm going to say this a couple times or try to show you. This series is identical to this function, both numerically if I have numbers and graphically. So if I graph 1 over 1 minus x, and I also graph this, they should look identical. But they're only going to look identical when x is between -1 and 1. So I'm going to go to my graph, and I'm going to go to my menu and just fix the window